Hi, I'm Nick, and in this video I'm going to show you how to cut and strip a wire to add to this LED circuit. Adding wires is going to make us more flexible when we build our circuits so that we can move our components around the breadboard. Here is an LED circuit. The LED starts at 5 volts, it touches a resistor in a row on the breadboard, and then the other end of the resistor touches ground. We took advantage of how long the legs on the LED and the resistor were so that we could stretch across the breadboard. But this limits our design. We have to stay very close to the sides of the breadboard. I'd prefer to keep my circuit a little bit more spread out. I want the flexibility to put the components anywhere on the breadboard. But then I'll have to use wire to make the connections because sometimes the legs on the components just aren't long enough to spread across the breadboard. Let's compare these two circuits. They're the same circuit. One uses wire to connect to power and ground, and the other, the LED touches 5 volts directly and the resistor touches ground. But that means that this circuit is stuck over on this side of the breadboard. If I wanted to move the resistor and the LED further away from the side, I can use wire to bring the voltages over. Breadboards are designed to use this kind of wire, but we'll have to cut and strip our wires to make the connections. You can buy pre-made wire kits or wire bundles, but I don't like to use these because they're the wrong color and the wrong size. So we're not going to use this kind of thing. We're going to make our own wires from a bundle of wire and some wire cutters and strippers. This allows us to be really good designers and customize our circuits. So let's disassemble this circuit, move the components somewhere else, and then use wires to reconnect it. I'm going to turn off the nLab while I work. So I'll move the resistor somewhere else on the breadboard, and I'll move the LED somewhere over here. So let's make the wires to connect this circuit. Take your wire bundle from your kit. We like to use red wire for power connections. So we're going to grab some red wire, and we're going to measure the distance from the row that has the long side of the LED to the column that has 5 volts from the breadboard. So it's going to be roughly that long. Then you can take out the wire cutters and strippers from your kit and find the cutter portion. The cutter portion is towards the middle joint. So I'm going to cut the wire roughly to length. And then I need to remove the insulation on either side of the wire so I can plug it into the hole of the breadboard. The amount of insulation we need to remove is roughly the depth of the breadboard, so about that much of insulation needs to be removed. The wire strippers have these alligator teeth. The bigger holes are for thicker wire and the smaller holes are for thinner wire. So for this wire, you want to take the wire, put it in one of these alligator teeth, the depth of the insulation that you want to remove, bite down on it, and then give the wire a little tug. The insulation should come right off. But if it doesn't, that's because the hole that we're using is a little too big. So I'll move the wire up to the next hole, try again, give it a little tug. It should come right off, so I'll move it up one more time, pull it right off. If you use a hole that is too small, you'll nick into the wire, and then the wire is likely to break right at that point. So once you find the hole that is good for your wire, keep using that hole. So I'll remove the insulation from the other side of the wire. And then I'll bend the wire into a U-shape and plug from 5 volts into the row that has the long side of the LED. So now we'll make the connection to ground. We use black wire for ground connections. I'll measure the black wire to length. I'll use the cutter and then the stripper to remove the insulation from either side. And connect the resistor to ground. Now we need one more wire to connect the LED to the resistor. This is an internal connection, so we can use any color of wire we like. I'll use some purple wire, measure it to length, cut it, remove the insulation, and connect the row that has the short side of the LED to the row that has the LED. The resistor. I'll double check that my circuit is built correctly, and then I'll turn on the nLab power, and our red LED turns on. So as you can see, this is the same circuit that we had before, but we just added some wires to let us move the resistor and the LED somewhere else on the breadboard. So take advantage of the wire when you're building circuits on your breadboard. It lets you be more organized and neat and creative on where you put your parts. Until next time, I'm Nick. Thanks for watching.